Trying to understand electric circuits, it can really feel like you need a PhD, right? But what if I told you it's actually as simple as a delivery route? Yeah, really. Let's pull back the curtain on the secret life of a circuit.
Okay, so for just a minute, let's forget all about electrons and, these invisible forces. Instead, I want you to picture a simple highway. That's it, just a highway. This one simple idea, it's the key to unlocking everything. And on this highway, we've got our main character, our hero, a little tiny truck. Its whole job, its entire purpose in life is to haul energy from point A to point B. And in our little story here, this truck, well, that's our electric charge.
All right, section 1, loading the cargo. So every journey's got to start somewhere, right? For our truck, that starting point is the loading dock. And in the world of circuits, that loading dock, that's the battery. I want you to imagine the battery is like this super busy factory. And inside, there's this chemical reaction just chugging along. And it's doing two things at the exact same time. It's manufacturing our trucks, the charges, and it's loading them up with their precious cargo, which is pure energy. Okay, so let's make this real. Think about a regular old 9-volt battery. We've all seen them. That little 9 volts printed on the side, that's not just some random number. Oh no, it is a very specific instruction that tells us exactly how much cargo each and every truck is carrying. Now, to keep things simple, all of our trucks are exactly the same size. In the world of physics, they measure the size of a charge in something called coulombs. So for our analogy, let's just say one truck is exactly 1 coulomb of charge. Simple as that. And here it is. This is where it all clicks. Because we're using a 9-volt battery, every single 1 coulomb truck that rolls out of that factory is loaded with, you guessed it, exactly 9 joules of energy. See? The voltage is just telling you how much energy each little package of charge is carrying. So that brings us to the textbook definition, but don't worry, it's not scary. Voltage isn't some fuzzy concept like power or juice. It's a very specific ratio. It's simply the amount of energy divided by the amount of charge. So 9 joules of energy for every 1 coulomb of charge, well, that equals 9 volts. It really is that simple. Okay, our truck is all loaded up and ready to roll. Which brings us to section 2, the journey begins. Let's hit the road. But wait a minute, what's actually making our truck move? Here's the interesting part. It doesn't have its own engine. Instead, you gotta remember that battery factory is just relentless. It is constantly cranking out a whole convoy of trucks, one after the other. It's basically a traffic jam. And each truck gets pushed forward by the one right behind it. And that constant flowing traffic, that is what we call electric current. So this whole thing is just one big, continuous loop. A round trip. The truck grabs its energy from the battery, cruises down the wire, drops off all of its cargo at its destination, let's say it's a light bulb, and then it heads right back to the battery, totally empty, ready to do the whole thing all over again. All right, now we're getting to the good part. The whole reason for this trip in the first place, the delivery. This is where the magic happens. So let's watch our truck. It's arriving at some component, maybe a resistor. It pulls in and it's carrying its full payload, 9 joules of energy. Then it unloads every last bit of that cargo right there into the resistor. And as it drives out the other side, it's totally empty. We're talking 0 joules of energy left, all gone. So that leads to the big question, right? The truck is empty. Where in the world did those 9 joules of energy go? Did they just poof, vanish? No way. Absolutely not. The energy wasn't destroyed. It was transformed. Think about its journey. It started out as chemical energy stored inside the battery. Then that became electrical energy for the truck to carry. And finally, when it got delivered to the resistor, it transformed again, this time into heat, basically shaking up all the atoms inside the resistor. See? Energy is never lost. It just changes its costume. Okay, so the delivery's made, the job is done. You think the story's over, but it's not. The journey isn't finished yet. Our little truck still has to complete the circuit. And even though it's empty, our truck doesn't just park on the side of the road. Nope, it's still stuck in that line of traffic, getting shoved along by all the fully loaded trucks coming up behind it. Its only mission now is to get back to the battery and get a refill. And this is so important. The truck itself, the charge, is never, ever used up. It just goes round and round. Okay, let's tie this all together. So in our story, the truck is our 1 coulomb of charge.
The cargo that it's hauling is the energy, which we measure in joules. That constant push from the traffic jam behind it, that's our electric current. And the delivery point where all the energy gets dropped off, that's our component, like the resistor.
Look, if there is only one thing you take away from all of this, please let it be this. The charges, they are not the energy. They are just the delivery trucks. That's it. They are the couriers of the circuit, whose only job is to pick up energy from the battery and drop it off somewhere else.
And that leaves us with one final thing for you to think about. In our story, that resistor turned the energy into heat. So what do you think happens if our little truck delivers its 9 joules of energy to, say, a light bulb instead? What would that energy become then? And that, right there, is the magic of circuits.